Hi, it's guys at UK here again. An exciting video. It's always an exciting video. If you spot the pan yet, an exciting video. Yeah, I get really enthusiastic about this stuff. Loads of components here, you can see. Wow, I'm not looking forward to fitting that lot. Oh my god, there's multiple pages. It's incredible that all of this stuff has come with this at no cost to me, which is again amazing. CPLD there. I've got lots of notes as we proceed through this build. Oh my god, I am horrified at the amount of parts I need to put on. And you'll have seen this hopefully on Glen's channel already. Diego 500. So it's a sidecar expansion that gives you Zorro slots in a nutshell. It's quite nice, isn't it? It really is. I'm amazed that Glen has managed to, he's pretty much, I think it's his first PCB project. I'm not sure if anyone assisted him with the build and the design in KiCad. He's probably just thrown himself into the KiCad. This is what he's come out with of his first project, which is pretty incredible, really. Yeah, so it goes into the Zorro slot, you know, not really the Zorro slot, but the sidecar slot, which is a kind of a Zorro slot on an A500 or a 500 Plus. And then you've got a co-processor slot here, so it's not just Zorro cards, you've got the co-processor slot as well that features on an Amiga 2000. And then he's got a couple of different breakout boards to break some signals out of the 500 or 500 Plus, you know, one goes on the polar and gives you extended interrupts. That's quite wild, that looks like a CPU one. Yeah, I think this is something to do with the BOS stuff, isn't it? So it's got like a BOS adapter, because the 2000 had a BOS signal and some logic around that to control it, whereby you could actually disable the 68K CPU on the board if you're using certain types of CPU in this slot here, you know, and you could switch between them actually. Commodore did that with the A2630. You know, you could boot, hold both mouse buttons down, and you got a boot menu. Do you want the 030 on your CPU card, or do you want the 68K? And it could intelligently switch over using that signal there. And when the BOS signal, you know, is low, if you like, to disable the onboard 68K on your 500. The idea being is it goes into high impedance, you know, everything's floating there so that it doesn't interfere with whatever CPU you've got in here. Because the last thing you want are two CPUs sat on the same bus, like trying to feed off the same signals and interface with the data bus and the address bus. I'm not sure what that says there, 21. Oh, I think, yeah, there was a mistake, I think. Glen said that two pins were flipped or something, so you had to cut a trace or something and put a wire maybe, I'm not sure. I remember seeing that on his video, actually. There'll be a link down below to Glen's video, so it's well worth checking that out. And you know what? As a throwaway thing, I'm sure I commented at some point in one of my videos that someone could do something like this. It may have been when I did the sidecar thing from Matsei that brought one Zorro slot. I've just got recollections of saying, so at some point someone could create an entire series of Zorro slots and everything with Buster. And because we've now got Buster in CPLD form from Live 2, Matt Harlan, the guy is incredible. I'm just wondering where it goes. I can't see a footprint for it. Maybe it's under here. Oh, there it is, Bluster. Yeah, the tape is covering it up. But the idea with this, and Matt's assisted Glen, he's done a change to allow it to be fitted on here. But there's a code change. I can't think what that code change is. But it's Buster that's responsible for the arbitration, controlling the buffering and things for the slots. I think Buster has a relationship to autoconfig as well. On the very early 2000, there'll be a link to that video top right, the board I looked at for Conrad Larsen. The first revisions of the Amiga 2000 that came from Germany. And it was the German side that kind of led the way on that. And they were the guys that came up with the idea of an ISA slots above this area here and making it sort of, you know, where you could put a PC into your Amiga. And some of the design decisions there were kind of eventually overridden by the US side, who decided to simplify things. And some of the chips, like Gary, for example, came onto later 2000s. You didn't have those on the earlier ones. You didn't have a Buster. You didn't have the BOS signal on that first revision. And you didn't have a Fat Agnes either. You had some of the clock gen done independently on that 2000. Anyway, check out the video for that top right. So, yeah, it's going to be quite a lot of work to build this, I think. Because I really struggle with all this SMD stuff. This will take me like a couple of hours or more to do all... Look, there's loads on the underside. A couple of hours to do all these SMD passives and things on the underside. And we've got a load of slots here. So we've got 4 Zorro slots, I think, and 2 CPU. Those are 86 pin. These ones are 100. 2.54 pitch card edge is what those are. I think I might have one or two of these Zorro slots, so I can probably fit the full 5, I think, even though I think I've got 4 there looking at that. Yeah, but anyway, I'll stick the slots on as the very last thing, I think. And as I'm building this, I'll tell you my genuine thoughts. I think it's incredible that he's done this. It's even more incredible that he'd send me one of his first boards and all the parts, so I'm very grateful. But like, would I choose to buy this myself? I wouldn't have done, so I'm really glad he sent it me. Because for me, I'm like, when you've got this giant thing that sticks inside your Amiga, and I feel like this way already, this is my views, I feel this way already about the POC 86 and the bridge board, the Zorro slot that Matthias Heinrichs came up with. I think they're great, but how practical are they? Well, I never use mine. It's easier just to get the 2000 out, because the 500 does take a lot of space up. So when you look at it from that perspective, it's a unique thing. Like, who's going to want to buy one, really? This is the thing, who's going to buy one? It's limited. You're going to potentially want one to test your cards, maybe. But we are back to the fact, if you've got a 2000, it's easier just to get the 2000 board on the bench. But as I say, don't mistake that for any kind of criticism. I'm not criticising it. I'm just saying some things, and I've got one of those myself that I'm designing myself, one of these things that you'll question, and I question. I'm like, how many people are going to use this? And in my case, the thing I've built, I'm like, me. Me. Who else is going to download it? I don't think anyone. I think, if anything, the thing I'm creating is even less useful in general to most people than this. So this is like better. This is better than what my board is that's coming up. You'll see what I mean. And that's the thing, we can design things not necessarily because they're always needed, but because we can. Why not? It's quite a nice accomplishment to have done this. And some people will love to be able to build and use one of these, without a doubt. But there are certain practicalities, aren't there? And this is the thing, there are practicalities with the project that I'm doing at the moment as well. I'll talk about that and refer back to this when I'm showing you that. In that what I'm building doesn't really make sense at all. It does for me. But in certain circumstances, it doesn't. Could argue just leave that flux on until I've done the resistors there, but I just don't want to get my hands covered in flux every 2 minutes. Yeah, so from a practicality point of view, having this big board stuck out your bench, that's the number one thing I think that most people, it's a foregone conclusion. It's like you look at something like this and you go, well, it's not really practical for me. You've seen the size of my bench here. It is definitely not practical for me. My 500, when that's on the bench, takes up all the bench space. I have no space for something like this, generally. So yeah, practicality-wise, it needs to evolve a little bit. And I was thinking, one thing that might be nice with this is if it's sat over the top of your 500, offset slightly, so that it doesn't obviously interfere with the keyboard. You could obviously do the same sort of thing where it fits under the 500, but then the keyboard is the thing that you're using on the 500. You kind of want the keyboard to still stay on the bench, and for something like this, maybe to sit at the back over the area where the 500 that you don't use, if you see what I mean. So this may lead naturally into projects to do something like that, to create an enclosure either at the side or on top of your Amiga. And I think that's where it becomes a lot more appealing, when you've got something where you can put cards in, screw cards in and all the rest of it. Because that's the other thing, when you're using this on a bench like this now, I suspect we'll probably need to remove the plates on the end of the card in order for it to fit on the table. But it may stand up sufficiently because it has got some standoff with it, standoff feet. That might not be an issue. You might not have to remove the plate. If you do like these videos, do consider clicking the like button down below, and please leave a comment. It just helps with the algorithm. Right, so I've got all the birdseed on. I finished that yesterday evening. It did take me about 3 hours to get all of this stuff on. It's quite a lot. most of it on the bottom side. Anyway, Glen actually took some feedback saying if these were resistor arrays, they'd be way easier to fit. I know Cavados disagreed, and Cavados was like, I don't like those resistor arrays, they're harder to solder. But I mean, for me, I'm talking about for me here. For other people, resistor arrays might make it harder, but it's less components, and I think Glen was saying it shouldn't affect the cost really. So anyway, I'm going to have a clean round now, all of the passives and things that are fitted on here. You could argue just clean it all at the end, but you know, it's the same thing I always say. The more you clean it as you go along, the cleaner the end result will be. And when you've cleaned up a certain area like this, you may then want to rework a specific component or two. And there are a few like that where I'm like, that cap's not very level or not very straight. So there's just one or two that need a bit of hot air. Adjustment with hot air, I'm not doing it. I think this is a 4-layer board, I'm sure of it. It takes forever to heat up one component. I'm talking like 4 or 5 minutes to just get one capacitor up to temperature. It's got to be more than 2-layer. And I kind of wondered whether it was 4-layer when I was soldering some of these components on, because you know, the iron heat sinks just a tiny bit in places, certainly when you're on a ground or a VCC rail. So yeah, and I was looking at these caps up here just before I went to bed last night, and they go to wires that go nowhere, so I'm like, nah, it's an internal layer. I was wondering why he had so many caps on it, because yeah, he's obviously got them for the different supply rails, but you've got ones down here for the supply, -5 volt supply, and then I was thinking, I'm sure it doesn't use -5. I thought that was just for the ISA slots, but -5 does go to the Zorro slot. Nothing to my knowledge I've got uses it. These 220s, you've got 1, 2, 3, 4, 5, I think, one for each slot. I found another Zorro slot connector or two, so I've got enough to do all 5 here. And then there's ones up here for like the minus and positive rails and things, and you know, +12, -12, -5, I think. Just looking at the way the positives and negatives are on there, so we need to check that, measure those, make sure all the right voltages are there and stuff before we stick anything into it. But we do know it works because Glen has done his initial video, but it's worth checking just in case I've done something wrong. You see what I mean? If you build one of these yourself, it's always worth checking before you stick anything in, just to make sure you haven't done anything wrong. It's, you know, we got some capacitors, but we got the CPLD 74 series. I've ordered some ALS chips for down there. We'll try it with the HCT ones to start with. And if we get any instabilities, I'll just swap out for the ALS. I wanted a couple of ALS in that size anyway. Yeah, you got an ore there. That's going to be for the auto config chain, isn't it, I think? So what Glen's done here is, you know, take the 2000 schematics, look at how the slots are connected up to on the 2000, you know, regards Buster, in this our case here, Bluster, and expanded the 500 really to be more of a 2000. You know, it doesn't have the ISA slots here if you were to put a 286 or a 386 or an XT card in there. And Glen was thinking about that. He was going to have some sort of interconnect to the top of the board here and have an extra board that's just got the ISA slots, but I don't think there's any point in doing that, to be honest. It's like the number of people that are going to want to get one of these is going to be much higher than the number of people that want to get one of these and get the ISA thing. You're just going to have a 2000, because the thing is, on a bench, you know, and I'll come back to the comment, where is it? Oh, up there now. It's not too big, your desk is too small. Well, that's a foregone conclusion with my desk. If I put a 500 here on this bench, there is literally no space for this on the bench. You'd have to move some of the stuff on the left side here to just about try and squeeze this on. So it's not practical by any stretch of the imagination, but that was the point I was trying to make earlier. If you could have a connector that came out and sort of went up and diagonally back a bit, you could have this on top of the back of the 500, but granted, it would need a lot of work to rearrange it. You know, your slots are going to be around the wrong way if you had it that way. I don't know, the white standoffs came with it. It's going to sit it up like that, so it does sit off the table. So the actual end of the card might not interfere with the table, so that might be alright in terms of, you know, testing without having to worry about it. You know, if it's flat like that, you see, and you plug a card in, your plate's going to have to come off the back of the card because it'll stick into the table and you won't be able to fit it in. But if this is stood up with the feet, I think it should go in. What I was thinking is I could use the ATX, but join the plus and the 500 plus 12 here, and the minus, I'm not sure if the minus 12 goes across there, but have it power the actual 500. There's an issue to point out with that. Obviously, when the power goes in through the power connector on the 500, you've got the choke there, and one or two other things, just little bits of filtering and stuff. So you haven't got that if you were to power it this way. I don't think it'd be a big problem though. I think it'd work fine, to be honest. Because, you know, ATX power supplies are pretty clean output generally. Yes, you need capacitors and stuff here, but I bet it would just work. So you could, in theory, just power your machine without using this back through the choke into the 500. Please do check out the link to Glen's channel down below. He does an amazing job on his channel, and this board is incredible. So this is the easy bit. You know, when I was first getting back into electronics, I was reminding myself of some of the SMD stuff I used to do, and I never liked it. Granted, back then there was very little for me to do in SMD. One of my early surface mount experiences was doing a RAM upgrade on an Atari. I think it was an STE. It didn't have SIMs. It had chips like this, you know, SOP type ones. The ones with a gap in between, you know, I can't remember what it's called now. J-leg type chips is what I think it used. And I always thought it was harder to do SMD, generally, than through hole. I would hate the idea of having to do anything SMD. I still didn't like SMD when I started doing the Neo Geo stuff. And then one day Stephen Lewis said to me, "Oh, through hole is so painful." And I'm like, what? Surely the SMD stuff's painful. But as I did more of the Terrible Fire builds and stuff, it just became second nature, really easy. And the SMD stuff, as you've seen here, the hardest bit is just anchoring it nice and straight. But it's really easy, and even when you get a bridge, it's so easy to deal with. Just if you've got good flux, it's very easy to deal with. I mean, I swear by this chip quick flux. Yes, it makes a mess, and it can make fumes if you know, using hot air on it. But it is so easy to do. It really is. Yeah, so looking at this, I don't have a U9, but we've got the ones from the Boss board and the Ian board. At this point in this video, I'm not going to test the Boss board. Right, so there's the update where we're at. The CPLD on next, voltage regulator, jumpers and stuff, get the ATX connector on and caps, and finish off with the slots. Right, so let's get the power LED on. It's very small, as you'd imagine it would be. So I'm not sure what colour that is. It's a yellow or green. It looks yellow to me. Right, that's that. So I always get confused with SMD LEDs. Best thing to do with this is put your meter on diode test and hope that you've got forward switching voltage. Hang on, it's upside down, isn't it? Let's turn it that way up. There we go. So we know this is the black, so the cathode is on the right. And if we put it on continuity, let's just see how he's wired this. Does one side go to ground, maybe? 0, 0, 0. Yeah, so the cathode is going to go there. It really is that simple. If I test the diode again just to make sure. Yeah, it's that way, so it's going to go this way. So there you go, it's a nice easy way to test. LED, you know, when there's no, because I can't really see a marking there. Maybe there is, maybe I just can't see it. Yeah, I think the way you go off these is the square end here, like there isn't one on that side. I think that means cathode, but I don't know. I couldn't be 100% sure before suggesting that that's the case. Anyway, I think the best thing to do here is what we did with the caps and things, which is to just get a tiny bit of solder like that. Use tweezy tweezers and try and tweeze it into position. Like that. And then use my finger. So just make sure it's flat, and it is. So hopefully I've got that the right way around. And obviously heat things like that for the least amount of time, because, well, it's got a plastic sort of surround and stuff, and LEDs from experience can melt really easy. Certainly SMD ones. Not normal ones. Good luck trying to melt those, you know, through hollowing. But like SMD ones like that, you only have to look at them with a slight temperature and they melt. Meaty meter on diode test. And it's not working. Why is it now not working? I think it's because... Have I got this round the wrong way suddenly? No. Yeah, I think it's because there's stuff connected up to it. There's a resistor obviously feeding this side, but where does that resistor go? Right, last few things. CPLD. Stuck to the captain tape. Sparks mentioned something about that captain tape in Discord yesterday. I can't remember what it was now. He's like, if you send me captain tape in future, can you send it on the... I think it's leave it on the reel. I think he means send him the reel of it, because it is good captain tape. It's so good that it's ripped all the things off the backs of it. Like the bandolier things that have had the caps and resistors on, it's kind of pulled the backing off on every one, and my captain tape's nowhere near as good as that. Right, where's pin 1 here? Right, pin 1's that triangle up there, I think. So just the same sort of thing we did before, really, which is, well, hang on, let's just see if we can see the print to make sure. Yeah, it's definitely the right way up. That's seemingly pin 1. I can't honestly see what's going on there. I think that's aligned to the left slightly. Yeah, and I've talked about this before. Don't try and get all 4 sides perfect. I said signs. Try and get 2 sides right, like I've got there, and get it generally okay. But then, hang on, oh my god, why is the solder not flowing there? I think it's this 4-layer thing that you get a ground or a VCC connection and it doesn't. Yeah, just push the chip, look. So you get a slight bend. They're mostly straight. I'm just going to go a tiny bit more. That looks pretty straight to me. I think I'm going to do a mod to my microscope, you know. Oh, we got a big bridge there, I forgot about that. Yeah, this is the thing, remind yourself when you've got remedial work to do. Remember all those bridges we left? An entire side bridged up? Yeah, I'd forgotten about it too. God, I didn't test it that way. Obviously inspection is the final part of the job on hand anyway. It's like way too much solder in the middle of that. Oh, what I was thinking getting that lot on there. We could probably redistribute now, just by going along like that. Right, ATX connector. It's got the little notch down here, so yeah, the notch. It's going to go the same way, isn't it? You could argue fit those caps before you do that, but they'll be easy, there's plenty of space around there. Oh, pins 21 and 22 are on opposite sides of the connector there, and they're flipped apparently on the 500, according to how he wired this here. So he's marked that. I've just coloured that pin green. I want to say, can we do something with a wire on the traces, because trying to do things with a wire on the actual connector is a bit annoying for me. Get onto one pad, float, copious amounts of solder. Yeah, try and inspect it. It doesn't look very straight, does it? Can't really see the pin up there. There we go. Yeah, it just needs a slight rotate pivot, if you like, to the left. There we go. Like that. Still not perfect. It's alright though. You know, you can see it's, the pad is there. Or the pin is in the middle of the pad, I should say. Let's just try and tilt that. That's it, that's what I go for. Tiny little balls there to mount that. You could argue that's too much solder. That's just the way I always roll. One thing I would say with the ground planes on this, they are punishing because it's a 4-layer board. Certainly these power caps here. You know, my approach of, you know, heat, you know, solder a point, just try and adjust it. Try and adjust it. It's like it sinks so much heat, it's insane. Now, as I say, some of these here are on a negative rail because, well, I can tell it's like the ground side's going to the positive. So when I spotted that, I'm like, oh, I hope he's tested it, but I know he has. So his caps didn't explode, so therefore I don't think I need to worry about polarity here. It's not like he's missed something and made a mistake. Oh no, that's what I don't want, because it'll be an unrecoverable scenario where I have to move the flipping thing. I want to try and get them pretty much right first time. There we go, that's alright. Ah, right, it took ages to get those capacitors on. I'll tell you what, no one could say that this board is not sufficiently smoothed. There's going to be 0.0% chance of any capacitors causing problems on, you know, missing capacitors on a design like this. Because he's, you know, replicated the 2000 design and merged a bit of the the Buster stuff with this Bluster. I can't get it right. Yeah, you know, he's got the best of everything. He's got, you know, the 2000 stuff there. He's got some stuff from Live 2's design, which is why we've got some caps and things around there as well. Yeah, it's really nice. I really like it. Right, just the Zorro connectors and the 86 pin. These are 100 pin, 2.54 pitch card edge, 86 pin, 2.54 pitch card edge. Yeah, thanks to Glen again for sending all of these Zorro connectors. I've got one that I've added myself. He actually included 4. On his bit of paper it said he only had 3, but he sent me 4. And yeah, they're very tight, very tight. Like, there we go, it's going on. They just literally hold them. You could probably test it like that now. It'd probably work without soldering it. They're so tight in the holes. That's nice though. Hang on a minute, we've got a pin pushed out here, see that? So that pin's probably just got a bit bent and I didn't thoroughly inspect it before trying to push it in, so I need to carefully pull that out. Yeah, just get that pin, hang on, and carefully just pull it back in. Up. That's it. Yeah, I'll just inspect with the little magnifier here, just to make sure I've got them all in. The modification here, he said 21 and 22. It's not pin 21 and 22. I've counted the pins all the way and I put the connector alongside this thing here. It's definitely fulfills the whole edge, but it isn't pin 21 and 22. So I'm confused by that. But I'm just going to go with the ones that he'd marked with his sticker, which is this one and the one directly below it on the other side. Maybe he numbered it differently on his design. I'm going to try and zoom in. I'm going to cut that trace and cut it at the point, let me think about this, I'm going to cut it somewhere here. Bear in mind this thing's vibrating like mad. It's another problem with 4 layers, and again I'm not trying to sound critical. See if I can work out where it goes. It's not the easiest thing to follow. I'm certainly regretting cutting that now, because now I've just remembered it's 4 layer. I think this is going to cause me a huge problem. Right, I followed it. It goes there on that connector. So I can show you that. I've just touched the bit of copper that's exposed on the trace. Yeah, it goes there. But obviously, it doesn't go to the pad. So that's good. I'm just going to put a green dot there on that, because that's where the other one wants to go, if you see what I mean. I'm going to colour that pad green. Yeah, there you go. I can't mistake that now. But I need to do a similar thing and cut it off here. Once you get a tiny, hang on, we'll start here. Get a tiny bit over there, and a tiny bit there. That'll do. So I'm going to use this Rich Radiance, came from Rich Palmer. I sent one of these to Glen, coincidentally. You can see some hairs there. Anyway, that'll come off when we clean up in a minute. So we'll just leave that there for 30 seconds to a minute, and that should set pretty hard. And then I may just put a few more bits, well, we are going to put a few more bits on the way just to secure it in place, and certainly a bit in between the connector. Yeah, because it has these standoffs like this, you could just sit it over and over. Just leave it like that for a minute, that's all it takes. I haven't need to use any heat in this, but I'll just show you. If I touch it with the tweezers here, it's solid. Yeah, it's had like 2 minutes, but it's solid. I haven't been looking forward to is preparing this. You know, you've got to squish these together. Under magnification, I've bent them fairly equally there. You know, keep just like inspecting, seeing which side you need to bend more towards the other. You see they're way too close, those two. There you go, get it on like that. Gradually work your way across. If you get stuck, just wiggle up and down like that. Don't ram it, because you'll bend the pin sideways. A little bit like that can help as well, up and down slightly as you go along. Yeah, so I did a bit of pulling it one way so that the PCB is totally straight, and soldering it and holding it while looking down at it, going, yeah, it's nice and straight. And then I did exactly the same on that one, because you want it 90 degrees perpendicular with the board, but I want the board right in the middle of the connector, which means, yeah, that should be it. It's just now a case of micro adjusting any pins, because there's one there that's bent across to the side slightly. Pushing any down that feel like they're stuck right up, and there are just one or two, and then solder at different points on each side, and then just fill in the gaps. That's my advice to you with something like that. Yeah, and as much as I dislike this solder here from Dr. Andrew with the flux, it's not great, it doesn't flow very well sometimes. I'm using that because it's a chunky reel, it's really thick. I'm never going to use it for anything else. So yeah, I'm just reminding myself this is what I use it for. Oh, the smell of this flux it's making me feel dizzy. It's that flux from the 80s and 90s where, I don't know, it's rosin based, I think, but it smells really strong. I remember fixing not a speaking speller, what was it, Operation. My dad may have fixed it once as well. And I remember smelling this smell when heating the solder points. You can't really see them very well because of the light, but if you look at them side on, the solder is like right up underneath. It's like bridged, it's formed a triangular wedge underneath that because this solder is so thick. And just heating the pin like that, it just goes all the way along the pad. So this is the beauty of using a really chunky flux like this. Oh, hang on. Occasionally you might bridge too. I've done that a couple of times now, and then just had to use a bit of braid just to mop it up, but it is pretty easy. So the following day, and we need to do some rework. I am glad I did not solder that on. I anchored it in 2 points, and then we soldered the 2 wires, which turned out to be completely wrong, because someone really helpful packaged this up and stuck everything in there, all the components, all at his own cost, and then stuck some amazing labels on to try and help me make a mistake. So thanks for that, Glenn. Thanks for all the amazing things you did there, but that sticker, keep your stickers to yourself, mate. It's like, if it was just written down, I think, and he may have done. I need to read the notes. You know what I'm like, I don't read the instructions. If I'd read the instructions, I would have read that the instructions contradicted the stickers, but I don't think it's on the instructions, to be fair. I'll confirm that in a minute. But anyway, Glen's got back to me and told me it's the, I think they said the 15th one up here. Well, the wire's connected to the 14th, so the trace that I've cut is the wrong trace, so I need to now remove this, remove my UV solder mask, remove the wire on this side. But the one on the other side's right. They're not, they're offset. It's like, I think this one's the right one up. Let's just count this here. 13, 14, 15. That one's correct, but it's not going to the right place. So I need to remove it from here, remove the socket, remove that wire, fix the trace at both sides, and then deal with the next one up, I think. Oh, 4-layer boards. Absolutely impossible to desolder those 4 pins. It's like solder's not coming off at all. The board's like, I've got loads of layers, mate. Screw you. It's like, it's not having none of it, so I'm heating up the desolder station. I've got no choice. The pin up here, I'm guessing that must be a ground. Kind of looks like it's right next to ground here. I don't know, it might not be. Anyway, yeah, got to use the desolder station. Right, I think I've managed to desolder those. I can't be sure. Let's just now see if we can. Let's have a. Ugh, this is the thing. Probably joined on the top side. It's going to end up with board damage, this, I can see. Feels like that should just come off, to be honest, but I heard a funny noise there then. Yeah, it's pulled that pin further into the socket. This is the thing, can you see that? That pin's sticking out, and the pin there is recessed just a little bit, so I need to just press it. I'm not going to press it, I'm going to do it like this. Hang on, let's just move that out of the way. Yeah, all looking good, good as new. If you want to see how to connect something like this up, watch some of the terrible fire builds that I've done. There's just a JTAG connection, 4 connections, TDI, TDO, TMS, TCK. And you've got to power the board, so it needed 5 volts, and I'll show you that in a minute. I've just bodged a 3.3 volt regulator onto the board, just temporarily, so that I could, you know, connect USB cable to feed 5 volts into that regulator, and then the regulator would provide 3.3 volts in order that the board can be powered. Right, so you saw me program that up, all went perfectly, no issues at all. Let's remove the JTAG, pull those off. And then we've got this other USB cable here for my phone cable. It's an old phone charger wire, you know, just a USB, and I just cut the end off and wired it into this. So the regulator there, I fitted this and measured the voltage on the pin here between ground and there, and I got 3.3 volts. I did that before I went into the other room with it, just to make sure, and check Shaw's, you know, continuity. But you can see it just bodged on an LM1084 regulator. It's the one that came off Andy's, what's it called, the PCI bridge thing, and we uprated that. It was on the extra channel, there'll be a link top right to that. Mediator, that's it. And someone was in the comments going, why don't you just cut it off, just put it in the bin? And I'm like, because I like to reuse things like this. It's ideal. The little smaller ones are a bit more weedy, aren't they, and a bit fiddlier to solder. This thing was easy enough just to bodge on in the way that you can see here. Just carefully put that there, and remove these blobs. So, you know, we've got 5 volts coming into it on its pin 3. There we go. Ground was pin 1, which goes to ground on the board, and ground on the board is joined to the ground on the same wire, and then I had 1 wire going across for 3.3. So I mean, it's that simple. It was easy for me to wire that up, but that's why I never throw things away, because, well, I can continue to use that for things like this, or if I end up building a project that needs one of those regulators, well, I've got one. Right, so I've got my ATX power supply here, and you know what, just looking at this, it's not, I can't even power this, I can't test it, I don't have a power supply to try it with. I can't remember which way it goes. Does it go that way or does it go that way? I think it goes that way, actually. But the point is, what are the connections on the end? I don't think this power supply outputs 3.3. Let's just have a look here. Maybe it does. Oh, it does. What? 3.35 minus 12. So maybe this will work. I'm just not sure. You can see this is the other problem with using an ATX thing. If you're going to have this on your bench, you know, what you're going to do with all your other wires. Granted, power supplies that may have the connector for that might not have all these Molex things here, and you might be able to disconnect them or something. So the question is, does it go like that or does it go like that? This is where I need to be very careful. It's those two there. You can see these two reds here, you see. I'm looking for two that join together, and I'm guessing these two on this end here are joined together. Yeah, they are. 3. We've got 3 there, have we? Yeah, that's right. The 3 oranges there, which are probably 3.3, is this pattern here. You know, the N2 and the one next to it. And then we've got the third and the fourth ones here are joined together, which is 5 volts. So it's going to go left aligned like that, I think. The question is, what's missing from here? I don't know. The other question is this going to go up in flames? I don't know. There's not much more I can do. I can't current limit it when I've got so many supply rails here. I've measured to see if I've got any shorts, and I can't see any shorts, so I don't know. Let's just see what happens. Hopefully it won't explode. Plugging the power supply in. Hang on. It's in. And I think to power on, we need a switch here. Oh, hang on. You see that didn't work. Or is it off? Maybe it's now on. Oh, it's coming on. No flames. No exploding caps just yet. LED is blinding me. Can you see that LED? Just put it down a bit. Yeah, it's absolutely super blinding me, that. I'm going to have to mask that out. I can't see what I'm looking at. Let's put that over it. It'll diffuse it a bit. And let's just measure voltages. Just put that in one of the tabs for the ground. So we've got a ground on the meter. Measure that there. This is where I measured it before, I think. 5 volts, and then I measured there. It's 3.3, I think. Yeah, 3.3. Got 5. Measure here. You can see I've got nothing on that pin. 12. Nothing. 5. So we've got our 5 and 12 there. These ones are going to be for the negatives. So it's going to be the opposite side. Hang on. Yeah, minus 5 there, you can see. And the other one... Ah, minus 12. We've got more. I just wasn't making a good fit. So we've got all of the supplies there. The LED's on. We've got the 3.3. Nothing's exploded. So I think that's a good sign. I think we can connect it up to 500. Right, I've got Rev 5 here. I'm going to go with this. I don't want to connect it to anything else just yet. What am I? You see, this is the thing. I haven't even got enough bench space to test it. That point on the other day saying too big, your bench isn't big enough. Yeah, right. Who's going to have a bench, you know, this big for anything, really? It's huge, this thing now. This isn't even a cased Amiga. If this was an... I can't even do anything here. I've got to move the power supply right across into the other room, more or less. Yeah, the other thing I was going to suggest to Glen in a minute are some fuses on this board, because thinking about this, my first reservation with connecting an ATX power supply up to a 500, me not like. I worry when I'm doing it with the 2000 and the 4000, to be honest. And is that loose, that shield? It feels a bit wiggly. Yeah, I've had experience with that before, when something goes short on the board. Oh, God. God, that's going to be... Oh, hang on, these aren't soldered in. Now I've got to be careful with those, putting brush on those Zorro slots. Need to make sure I didn't squish that there. Yeah, the point is, ATX power supply, high currents it can provide. In theory, if something goes wrong on your board, it can go very badly wrong on your board. Just so you can see. Yay! So it's booting the Amiga. Ignore the wavy lines. This is the thing you get with some ATX power supplies. This is the problem with another thing for me using this ATX power supply, because I've noticed whenever I use this ATX power supply, this is what I get now on my 3000, on my 4000, on anything I'm testing, including arcade boards. But it is powering the whole lot, so I'm very pleased. So far, nothing exploded. Right, let's take the CPU out, and then I'll go and get something to stick in there. Oh, it's a normal socket, this, isn't it? Right, SD card filled up. It's like 32 gigabytes of footage to remove off it. So it shows back that way. It's got to be the same way it is on the 2000, isn't it? All these Molex connectors are really annoying. Right, I've got to try and press this in now. There we go, that's it. Fairly firm. We've removed that, and let's see what happens. Yeah, nothing's hot there. I don't know, that should be working, but it isn't. Surprised that, really. I don't know. Is it this card? Oh my god, that's impossible to get out. It's just the problem with new connectors, you know, when you get brand new connector, you can't get anything in or out off the flipping thing. So the 520 doesn't work. That I'm putting down to the 520. It might not be. With the, and this is the thing. When you expand something like this here in this way, it's never going to be like for like a 2000, because you get timing differences and stuff with the way the traces are routed and through the impedance through a connector and all that's, you know, solder point, solder edge, or it is gold plated actually the edge of this, but you get subtle differences there that mean it's not going to be quite exactly the same. You could try the 536, which isn't killing my various cards. So let's try this. It's not got a compact flash in the moment, but let's just give it a try. This is the 536. See if we get any further with that. Same thing. Yeah, so just a black screen. I'll switch it off again. You see we get the RGB to start with and then nothing. RGB. Nothing. Don't even see the lines. We should see coloured lines on the 536 and we don't. I'm going to have to confirm with Glen it is, you know, the pins that we've got mapped there. Is he sure it's the 15th one up? I bet he comes back as it's the 14th. I'm going to be going round and round and round with this, aren't I? Just thinking, is there anything else? I've not missed anything else. Everything else is right. You know, everything's on there. This the CPLD is really good. No issues there. The only thing that's not soldered are the Zorro slots. Oh, hang on a minute. It's 28 megahertz, isn't it? Ugh, I forgot about this. This is another thing with it. But when you got wires involved, it's the reason with the E-int stuff why I was saying to, where he put the comment on the silk screen, I said, oh, just don't bother, I wouldn't bother if I was you, kind of thing. Because the extended interrupt stuff, it's trauma having DuPont wires, the very loose connections. DuPont, they're so unreliable. You can get something like that connected up and it'll work for an hour or two. Disconnect, reconnect, that's it. You lose connection, real loose connection. It'll be flaky, it'll be fluffy, it won't work. So DuPonts, try and avoid using DuPonts to connect between things. I know Stephen's got a few of those on his and I have no end of trouble. My 500 plus board's got wires coming off it with DuPonts to, you know, periodically connect up to certain mods. And when I do that, I have no end of reliability problems with DuPonts. So that's something to think about. If you want a connector, something else. But then now we've got to tap the 28. So I'm like, where do we get the 28 from now? I don't know. I need to go and look at this thing. And I'm not, like I say, I'm not trying to sound moany here. Right, I was getting nowhere with CPU cards. 28 megahertz I brought across, nothing, just nothing at all on either the 536 or the 520. It could just be those cards, because this is the thing, I know that those cards were well tuned for a 2000. And whilst I got the 520 and the 536 working in here, yeah, in this slot here, yeah, it struggles, so you start sticking it at an extended distance, you know, in a slot like this. I think that might be the issue. I need to do more testing, but anyway, I soldered the first Zorro slot on entirely, and that's working. As you can see there, we've got 8 meg. No worries. And we obviously got slow memory in the expansion and half the mega chip on this because it's got an 8371. So the Zorro slots is looking very promising, isn't it? First card's working okay. So for now, I'm going to solder up the other slots and work my way through testing a bunch of different Zorro cards. And you can argue that's the main feature of this. It's like, I'll be honest, if I was going to get one of these, or if there was an option, you could get one without the CPU card and one with just the Zorro slots, etc. I'd go for the one with just the Zorro slots, because I would have no intention of using the CPU slot there. For one thing, some of the CPU cards are quite long. I wouldn't want a really giant long thing. But, you've seen the size of the Live 2 card here, and a lot of them are like that. They're just like as wide as the slot modern cards for the Zorro. So it kind of makes more sense, and it's nice to have 5 slots rather than 1. And if you think about it, if you didn't have this here, then, yeah, you still need the buffers, but you could, I don't know, maybe it could be compacted a little bit, I reckon, with a bit of a design. Yeah, a redesign, slightly. So, I don't know, maybe do away with that. This is just my opinion, but other people might want it as it is, and like it as it is, and get it working as it is. I'm just thinking about, the thing about E-interrupts, I'm not going to use them. It's, I don't think anyone would. The problem with the 28 megahertz at the moment is, well, it doesn't seem to be working with my CPU cards, but it may work with, one or two others. I'll need to test some other ones. I'm not sure what I've got, actually. I've got another Terrible Fire I want to try. I could try my 534. I've also got the A2630, but again, that's quite a long card. It's going to stick right out over here somewhere. And would I use that, with one of my boxed, cased 500s? No, I wouldn't. I just wouldn't do that. It's a crazy thing to do, really. You can argue it's crazy to have the Zorro slots here, but when they're only taking up that much space, if the power supply, the ATX power supply, wasn't cheesing me off, if there was some way of powering this without having this big cable and everything, then it makes more sense. And likewise, if this was cased, and that might be the evolution for this, if this was in a case of some sort that stands up so high, so you can have your slots in it and you've got a power supply built in, yes, you've got this huge box that sits next to your 500. For some people that might be usable and desirable. Again, I wouldn't dream of using something like that. So I think this is the reason why no one's done this. It's like many people, including me, have looked at the schematics and thought, build a load of Zorro slots on there and stick a buster. Now, because Live 2's created Bluster, Glen spotted that and thought, that's even easier, because you don't even need a buster chip anymore. You can just have the CPLD on there. It's nice. I'm not really sure how practical it is the point. But I always felt this way. This is not a criticism of you, Glen. It's not, this is the thing. When I look at the POC 86 and the Zorro adapter from Matthias Heinrichs, I've always thought that about those. They're a nice, gimmicky sort of thing to have, because you can test quickly a Zorro card, you can test quickly the CPU card. All right, with this, you've got to remove that. At least Glen's put some effort in there with Boss. But again, it's a problem that no one really ever had, if you see what I mean. That's the thing. And I was like to say, I thought long and hard about how to best present this in a way that, because what I don't want to do is offend Glen, but at the same time I've got to speak reason and logic, really, to a degree. When I design things that are crazy, I'll point out the crazy. I've got one of those coming up where I think it's only going to appeal to me and maybe one other person on the entire planet. But it might give some ideas for people to want to create other things. And I guess this is the thing with this, that Glen, for his first project here, it's just absolutely incredible. Hands down, you've done an amazing job, you really have. You've thought of pretty much everything, apart from who's it going to apply to, yourself, and us geeks, like me, really, just testing things on occasion in here. I can argue it might be convenient to get this out rather than 2000 board out, but you know what? When you start having to join wires up, all these different things connected up to the motherboard here, and it's much larger, it's easier for me to just get a 2000 board on the bench and use the Zorro slots on that. So whether this is something you're going to want for your Amiga is up to you at the end of the day. I think there's nothing wrong with it so far, apart from the fact I can't get the CPU slot working. I think it's really good. It's amazing. But I think it'd be wrong of me to say, this is amazing, everyone is to rush out and buy one, or make one, now, because what would you use it for? Unless you want a load of Zorro cards and CPU cards sat on your bench, extending your 500 even bigger than it already is. I always thought the 500 was huge. It's huge. I actually think the Atari ST is small. The Amiga 500 and 500 Plus are really wide. The last thing I need is more things to widen. But from a technical standpoint, it's amazing. It's gone around the RAM range there. On the initial test of the Zorro slots there, that first slot is working. I'll solder up the other 4 slots. We haven't got the standoffs, so I need to stick those in, don't I think, because then it fits a bit flatter, you know, it would sit up like this, so we'll perhaps do that next anyway. It's not sagging too much. Switch that on. Just making sure that is right. That is right. 8 meg. Test all. So the Zorro side, I seem to be having luck with here. I'm quite happy with this. Everything so far is working. We've tested the first slot. This is the last slot. I'll let this go around until it's on past 2 or past 3, and then I'll just work my way right through the slots and let you know the outcome. Yeah, slot 5's gone round. Slot 4. Yep, 8 meg. Switch it off, and let's do slot 3. Only slot 2 to test after this. Yeah, 8 meg again. Switch it off, and let's do slot 2. And that will mean all 5 slots have been tested. The full 24-bit range there with 8 meg. 8 meg, what I like to see. It's looking good, isn't it? So it's still testing slot 2 there. The next thing I'm going to test is Booty McBootson here. So it's the A2091 with SCSI. SCSI to SD, is it? I forget which one it is. I think it is. There'll be a link top right for this video. We totally upgraded it and stuff and did some modifications and things, and it should be nice and stable. Let me just see the state of the buffers on this. Did I leave it with ALS? Yeah, I did. 74 ALS 245, 74 ALS 245. Not the same manufacturer, but anyway, that's the way I left it. It's much more stable with ALS chips, and the 2000's much more stable with ALS chips in the data bus buffer area there, but with these, I think the HCT, it seems alright. I think I tested HCT when I was experimenting with the problems with the SCSI, and it didn't really solve the problems. ALS chips did. You know, there was some instabilities with this card, with long file transfers, unless I had ALS chips on the motherboard, but putting them on here as well just sort of doubled up the stability, really. It just made it even better. And slot 2's passed as well. A fun fit on here, isn't it, with this wires and things. You see, this is the thing that plate is now going to catch, and I think that would catch even if this had the feet standing it up a bit. So I need to take that plate off. Oh, it's screwed right into there. Stupid thing. I'm not taking that off because it means undoing all the SCSI drive and everything. I'll just support it up or something. Oh, do you know, I'm so traumatised doing this. Because it's like, I've now got to somehow support the board off the bench. And, well, everything. How do you even lift this all up at once? It's going to end in tears, this out. Power supply is going for it. Have you ever seen anything as dodgy as this? Got to watch all these Molex connectors, and then when you can get that in properly now, that's it, it's all the way in. But just look how tight all this stuff is here. It's not practical. Got to be careful not to plug that anywhere. Yeah, it's just not practical in any way, shape or form. Right, let's try that. It is a bit precarious here over the end of this box. I'm just watching the SCSI to see if I see anything. And I don't. Mind you, I'm not sure I can see the LEDs because of the power cable. Yeah, it's working this time. The Amiga was not booting. Now I've got the white screen on the Amiga. See what happens there. I'm going to get a problem with the drives, I think, because I've got an older version of Kickstart, if it boots. But I'm not sure if that's just like stuck on now. It kind of looks like it. Yeah, on the basis that it's been sat around for a while and not been used. I was cleaning gold contacts up here, but you know, they look pretty clean. There's a bit of grey coming off them. I mean, the reason I named this card Booty McBootson is because it's so damn reliable. After the video, any of my 2000s or even the 3000 or 4000 boards just works. It always works. Never have a problem with it. So even though this has got ALS chips here, I wouldn't want to change those just to prove that for some reason it might work a little bit better with LS chips on there, because every other Amiga I put it into, I even tried it in the GBA 1000, I think, this card. Oh god, Bennett. It's annoying that power supply connector there's not longer. I mean, it's not hindering the card in any way, it's not pressing or anything there. Right, let's try that after that reseat. I think we'll try the GVP as well. The GVP is perhaps a little bit more forgiving than the A2091. Now we've got yellow screen, look. Let's power cycle it. I'm going to hold both mouse buttons down, just to see if we can see the early boot menu. If we look at expansion board, yeah, so it's seeing the... I'm trying to think, why have we got two there? Yeah, one's RAM, one's SCSI. Let's just do boot. Flashing, flashing, flashing. We might hit the desktop this time. Fingers crossed, fingers crossed, fingers crossed. Oh, we've got a desktop. So we didn't the first time. We haven't reseated anything, so it just seems a bit fluffy. I'm wondering why that's got a different icon. QDH0. I think that's the system, isn't it? Yeah. It's just the way I labelled them up. Well, it seems to be working. Yeah, the 536, we get a green screen there. Just occasionally. I think Cathete got is working. You see, but it might dictate, or it might be dictated by the revision of your 500. So, because this is a Rev 5, it's giving me a green screen. So with the 8A, I've removed the CPU straight away, actually the PyStorm in it. And we'll get a 536 straight into it. We got the bands, so it is working with a later A500. The Rev 8A, I think this is 500 plus. The next thing is to just get a compact flash card into the 536. There you go, so it's booted from hard disk. At least we should have a load more RAM here now. We should have 2 meg of chip roughly. Yeah, and 64 meg of fast. Woo! The main thing is, I feel so positive now because my normal wires are right here. It's not something I've done, and there isn't something fundamentally wrong with it. It's just it likes the later Amiga boards better. I will test the A2091 again. Maybe it's just happier with the Rev 8A. Right, let me go and get the 520. I want to see if that boots. There you go. So the CF520 works fine. Yeah, if either me or someone else developed a little module that could fit under the 030 footprint on the back of the board, solder it on there, in theory with a tiny bit of address decoding and a couple of RAM chips you could add, I don't know, 32 meg or 64 meg, and then it would be a really nice card, just with like a little add-on PCB. But yeah, it's booting every time reliably. It boots better here on this than it does on any 500 board straight in the dip socket. That's for sure. I've got a Ripple in here. I only got 2 of these left. One of them has gone CRG. All of them have gone CRG actually, a big pile of them. 3 I think. CRG and Hack Build Restore. So watch their channels coming up. Could be a month away yet, so don't put any pressure on those guys, but I've sent those to them. And I'll do a video showing you what's happened. But that's booted. The Ripple has booted on the TF520. Obviously we've only got 2 meg of RAM, haven't we? And yeah, just 2 meg I think. If we go into Workbench, I was going into my utils, I don't see any point. I could do, yeah, sysinfo would show me not a lot. Yeah, we've got about a meg left after booting up. Should be able to load a game though. Yeah, expect slowness when you've not got any additional RAM. Well, perhaps stick Live 2's card in there in a minute and give it a bit of fast RAM. Yeah, that's the stereotypical WHD load, moving things in and out of chip RAM, caching, you know, it's trying to decompress things. You don't have enough RAM. It's working though. Hey! Fantastic. Right, let's give it 8 meg more of RAM. It should perform a lot better, that game, as well, you know, instead of having that black screen flashing thing. Yeah, so really quick loading that. Just realised to get out of this now, I've got no keyboard, I need to reboot it again. I'm already impressed with the IDE speed, to be honest, with the ripple on the 520, TF520, because it's throwing the icons up there pretty quick. You wouldn't get that on the standard 68K. Yeah, just over a meg. So that's definitely better than you get on the stock 68K. You know, it's frequently loading from the disk, which is a nice way to test IDE. That's fine, and we've certainly got enough throughput there, it's not stuttering. And this answers a guy that was asking me recently about the 520. He was like, have you got it working with the Live 2 card? And I'm like, yeah, I'm sure it did. Well, we've got 8 meg there. Alright, might not be using that at the moment, it could be using chip RAM, but the bottom line is we've got everything configured there, and everything seems to work. And I'll bet that if I was to run testkit now and test the RAM out there, I'll get a full 8 meg without an issue. You know, it may depend on what 500 revision he's got. The guy who's trying to get one of those working. And it might be the adapter he's got. You know, these are not all the same. Some of them have got better grounding and better layout than other ones. But I think we can call that a success. Green like this. Because then it's absolutely obvious to me when I come to connect that power supply up, not to connect there. Right, so I'm doing some modifications that Glen has suggested here. He's worked out a few fixes. The first one is this cap and this resistor on their own here. I was wondering why this, you know, this is separate from all these buses of connections here. It's a bit weird. But anyway, turns out it's wrong. He's saying cut that trace there, so I think that trace there. I'm just wondering how these are joined up, and it looks like the resistor's going to the cap and then to a pin, which is a bit strange. Yeah, and looking at the schematics, that's actually right. I'm surprised at that. That's just the way that Commodore went with it. Right, so let's use this. It's worth checking things when you find things that don't look what you'd expect. Not really sure how to best approach this. It's the sort of thing, if you do it before you assemble the board, then it's far easier. We've got no choice now, we've got to just do it in situ. So let's try and grind this trace here. Yeah, I'm confident that I've cut through that, I think. Yeah, we'll get some UV solder mask onto that later. I'm just going to leave it for right now though. So that's that one done. Right, so the next one here is a 4.7K pull-up added to BOSS. So I'm just looking at the pin out of the CPU slot here, yeah, underscore active low BOSS. Goes all the way over to what looks like pin 20. There we go, 20. That's easy. Anyway, we know where it is on this jumper here, so we need a 4K7 pull-up on there. Right, so I've got the meter on ohms there. We now test from BOSS to the 5V pin there, 4K7. So we've got our 4K7 resistor there. Now I need to get them on all of the eInt lines, which are all of the lines here. Now this is where I'm going to do a different approach, I think, and I'm going to solder SMD resistors out from each eInterrupt line there, have them floating over the board, and then join them up with a wire and make like a bus, if you like, so going down to, well, back up to this pin here actually again. So I'll have a wire coming from there, but I'll use a load of SMD resistors, otherwise, well, it's just going to get messy, isn't it? I'm going to have resistors all over the flipping place. Now I think about it, that was a stupid thing. Mind you, we needed the connection here. Oh, I don't know. I should have just stuck SMD resistors on all of those pins there, joined them all up with a wire to the 5V here. Might remove that resistor in a minute, I don't know. That would have made more sense. I didn't read the next step. I got to the next step and then thought, if I'd read it all in one go, I would have had just like a bus of resistor connections there. Yeah, I feel so much better now. I'm not going to remove that resistor at all, because I found some 4-pin, not 5-pin, but 4-pin 4K7 resistor arrays, and I could just solder this straight down on the pins there and just join one wire up to here again. So I didn't really bodge that up at all, if you see what I mean. Hang on, try and find the flipping thing here. Yeah, so boss is the top, which is the bottom, and then it's the next 4 pins. And then the E-int pins, 4K7, 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 thank goodness for that. Yeah, so there's things before, some of them are stressing me out a wee bit. Trace of right hand side of C34, top side, which we cut, that's that one, on top side. And wire run to pin 95 of adjacent Zorro slot, i.e. the pin directly next to it. Oh God. I'm thinking, how am I going to join a wire from the top? This is the thing, it's all very well joining a wire from the top here, of where we cut a trace that it's an impossible space to get into, to the right, so here, the right hand pin, presumably. You can't do that. I think it makes more sense to just stick a resistor where a resistor is required, assuming that that's what he means. I don't know. That's not very clear to me. It'd be better just to, I don't know. Would it not have been better just to have removed the resistor, yeah, and then you can leave the trace intact, and then join something to the pad rather than cut the trace? Yeah, that would have made more sense, because now I could just have I think so. I don't know. Let's leave that one for now. The next one is 10k pull-ups, I think, on the EBR lines. And here's a tip for you: if you've got really packed component trays, like I do here for these resistor arrays, get yourself a piece of card, and then when you push it into your drawer, these things will not flap upwards, you see, and catch into the trays above. So yeah, I have these little card flaps like that. It allows me to maximise the stuff that I put in a tray, and no fear about it getting stuck. Right, and that concludes my 5 bodgy long wires. We have 10k pull-ups on the relevant pin there. It was 60, wasn't it? Yeah, so I'll count down this way. Yeah, and this wire, it needs to go to 95 on the Zorro slot. So I think the best way to do it is to join it, rather than trying to join on a trace. Yeah, it's alright when you're modding the board right from the start. We've got our slot, so you know what, we can't stick a wire going to the pin on the slot. But what I can do is try and squeeze that in there like that. That's it. Pull it over the board. Pull it straight round, and it wants to go to 95, which is the CBR connection. So let's get the 2630 in. Now there is a jumper on here. I did make a note of it, I'm sure. I stuck a label on it. Maybe I didn't. I think it's 302. Anyway, if we get this in, this is the 030 CPU card. It's going to go that way. We'll try it initially without this in and just see what happens. I just want to see, does it boot or not. I think it's not booting though. I think this is where the boss thing is a bit of an oddball with the CPU. So you know what, Glen said he'd sorted the boss stuff out without having the boss adapter board. So I'm going to stick the stock CPU back in, because this card should support this feature. Let's try that. Saw RGB then. Oh my god, it works. So that has resolved it. Well done, Glen. Fantastic work. And the proof of the situation really is if you get the mouse in, and remember, let's just try and hold the right one down, switch it on. Hey, there you go, there's the secret menu. So we can choose 68,000, see what happens with that. Oh, there we go. We're only going to know if that's a 68,000 if I boot from floppy, but we can do a stage further and boot from hard disk in a minute. And this time we'll choose 030. Yeah, so that seems to be working. Right, let's take it a stage further. Oh my god, I've just remembered I need to lift the flipping thing up, don't I? This stupid plate on the back again. Don't do as I do. Right, let's try that, see if we get anything. Just watching the LED there. I'm like, oh, it flashed the scuzzy. Yay, it works. So there you go. Glen will be super happy because 2091 works and the A2630, he's solved it with the number of mods that we've done there. And if we go into Workbench, my utils, I can tell what's running on the 030. It's so much snappier. Go into sysinfo. If that was a stock 68K, it would be a bit slow. Yeah, you can see there 68030, 68882. So MMU's not in use. Mustn't have an MMU, this one. Let's have a look at drives. We'll do a speed test on it anyway. It's a good idea, and we'll just launch a game or something, maybe TimeGal. It's just to make sure it doesn't sort of expire, die as soon as we do like a SCSI transfer. Because that was his concern, whether DMA transfers were working okay. Yeah, 871k, that's about right. It's been an absolute joy testing this bench. I'm going to ask the wife if we can move house. We need a bigger house. Diego doesn't fit. Yeah, testing of the games out. It's working fine. It's solid. Absolutely solid. Before I forget, massive thanks to Oddbod when he sent that card when I lost my job back in 2019. We upgraded it in a previous video up to 4 megabytes. So at the end of that epic journey, I thoroughly enjoyed building it. I think it's extremely impressive that Glen has come out with this as pretty much one of his first, that I'm aware of, first PCB projects. We ended up with a couple of fixed wires because of a mistake in the design, and then all these things he missed, just resistors. But it's a large PCB. I'm amazed he didn't miss more, and I'm also amazed that he spotted the things he missed really quick. Within the first week he'd worked out these resistor arrays that he'd missed. So there's very little wrong with the original design, really. You could purchase one of those original ones and just do the 4 or 5, 6 maybe modifications to it, and it works solid. Now, I didn't revisit back on the Rev 5 because that was a bit sulky with CPU cards, but the Zorro slots were fine on the Rev 5. And it did work with CPU cards a bit intermittently. I think that was maybe a reflection on the 28 megahertz crystal. It probably needed buffering the 28 megahertz clock. So that's maybe another thing you could do to something like this, is maybe stick a Schmidt on the 28 megahertz coming in, possibly. Maybe via a jumper, so it could be an optional thing, either go straight through or it's buffered with a Schmidt. Yeah, that green mark has worn off there a little bit, but it's obvious for me to left align it. I think it's incredible, I really do. I didn't show you the feet, they're in here. So they're the ones you get like an 80, old 80 cases, for PCs and stuff. And they just go under there, and I've measured up, it stands off the table just the right height if it's plugged into an actual 500 or 500 plus. So those are certainly useful. But I'm not so sure there's quite enough clearance for some of the cards, with the plate that comes out, because they come out quite a distance. I'd need to retest that. I might do at some point when we get an actual cased 500 onto the bench. So there were some components left over for the board here, but we borrowed, this is the E-interrupt board. We didn't build it. If you wanted to get true E-interrupts compatibility, you use obviously the pin header here and connect it to a pin header on this, and this goes under your Paula, I think. And then the other board, which I ended up throwing away, was the boss board. And I did film the building of that, and I built it, and got right towards the end and realised I stuck the pins on the wrong side of the profile. And desoldering it, and pulled off about 20 or 30 pads. So I was like, asking Glen on Discord, Glen, have you got one of those PCBs I could buy off you? And he was like, oh, you don't need it, because the code that I did, the latest one, and I'd already flashed that to it at that point, I didn't realise, the latest code handles boss without the boss board, so it's only really the E-int board if you want to use E-interrupts, extended interrupts, but I'm not aware of any Zorro cards that use it, so it's there's no point in building that really. Yeah, I tried to get myself some ALS chips, and I went through about three different orders, and every one of them's wrong. These were the last ones, you know, the tiny look compared to down there. So I don't know what Voodoo, and these were the other ones. I don't know what Voodoo chip size you went for here, Glenn, but it's like, those look right, but they're not. They're a bit wider, which means they don't fit on the pads, if you see what I mean. Yeah, they look almost right, but they aren't. Yeah, they're bigger. It's about 20% too big, that. Anyway, amazing stuff. Do check out Glen's channel down below. I think that's incredible. I really do. I'm blown away with that as, you know, a first product, if you like, from Glen. I think it's absolutely incredible. And please, like I say, don't take anything I said in this video as any kind of criticism. It's not. You saw the fun and games I had testing it in terms of the physicalities, the practicalities of having something like this on your bench. I think if this was in a nice case and Glen was looking at the idea himself, you know, 3D printing parts and things, you know, you could get some of those little hex standoffs and build a frame for it or something, you know. It could be quite, you know, well encapsulated, something that sits on the side of your machine. And the point I made earlier, if this was an optional thing, and I don't want to give Glen more work, but if it was just the Zorro slots with a bluster, you know, you could put some of those things on the underside 7.4 series, perhaps, with a bit of effort. I'm not saying it would be easy, I wouldn't like to do it, but the point is, if it was a bit smaller, it's going to fit on the bench a lot better, isn't it? And then in terms of a case or something, it's not anywhere near as big. And maybe it makes more sense. The complication, I guess, from my testing anyway, was if you use an ATX power supply here, the cables for those are really big and chunky, and you get all the other things flying off it. Maybe not on a brand new one that's got this wider connector. You might have optional Molex things where you can just unplug all that stuff and just have the ATX power supply connector. But still, they're a short distance from the power supply, aren't they? So that's the thing. You know, ultimately an evolution again. And again, I don't want to create more work for Glen. I would say it's not worth pursuing the next step in terms of doing something with the power. Maybe have some power generation on the board for the different voltage rails, but fed from a single power supply. I mean, you could use one of those micro ATX adapters. That would make more sense, wouldn't it? I'm not sure whether Glen did that or not, I can't remember. But you could get a little micro ATX, and then you're just providing it with plus 12 volts. That's far easier. So you can argue there's nothing really to be done there, and I just didn't do it right. I used an old huge power supply. Yeah, so please check out Glen's channel down below. Thanks ever so much, Glen. I hope you found that interesting. I'll catch you in the next video.